Today we're going to talk about fractions and adding and subtracting them, and then dealing with distribution and factoring things out to simplify them. Adding and subtracting fractions is by far the worst thing about fractions. Multiplying, dividing, super easy, just multiply across. Dividing, we have a bunch of strategies to use, including multiplying by the reciprocal, but with adding and subtracting fractions, you have to have the same denominators, right, in order to do it. So as is right now, we cannot combine these terms. They're not like terms, right? This is 4 over a, this is 3 over 2b, and this is a minus 2 over 3c. So 3c, 2b, and a, obviously not all the same things. So there is a strategy that we can use that works every single time. It's not always the most efficient, as we'll see in the next problem, but it works every single time to make these three terms combinable into one term, or to write them as one fraction. So if we really want to write it as one fraction, what we can do is we can get common denominators. We can get these to be the same. And the way we do that is by not changing the problem. So we're not going to multiply just by a number or something and have these guys change, because obviously timesing by a number would make things bigger unless we're multiplying by 1. And that's what we're going to do. So let's just focus on these two for now, these two terms. If I want these to match, what I can do is I can multiply this term here by 2b over 2b. And the reason that I'm allowed to do this, of course, is because 2b divided by 2b is just 1, right? Anything divided by itself is 1. So when I times 4 over a by 1, I'm not going to change what this value is. It's going to stay the same. So when I multiply this, I'm going to get 8b over 2ab. And some of you guys are like, oh, this will simplify. Yes, of course it will, right? We'll be able to divide out 2 and b from top and bottom. That's why we put it there. Leave it there for now. We've got 2ab on the bottom now, which is going to match what we get over here. So by the same logic, I'm going to multiply this one by this one's denominator. And what will happen is they'll end up matching, right? Because I'm going to have 2b times a in the bottom here. And if I multiply by a over a, again, timesing by 1, so it won't change this. I'll end up with 2b times a in the bottom here, right? So I'll get 2ab here, and of course, in the top, I'll get 3a. And I'm still adding these two. Now, because they have common denominators, we're talking about the same thing. 8b's of this, 3a's of the same thing. We can write it all over 2ab, because all this means is divide this by 2ab, divide this by 2ab. Well, we could just divide them both at the same time by 2ab. Writing it like this. Now I can't combine the top two because b's and a's don't go together, right? They're not like terms, but that does get it to be one fraction. Now I still have this minus a minus 2 over 3c here. Let me do a nice big subtraction sign. And there's a bunch of things we can learn from this last little bit. Just dropped my pen cap. A minus 2 all over 3c. Cap. All right, so there's two terms in the top here already, which is interesting. There are a bunch of ways to handle this. I'll show you one way. We're going to use the same method we used for the original part to get these denominators the same. So I'm going to multiply by, over here, 3c over 3c. And of course, that will not change this value because I'm just timesing by 1. And then over here, I'll multiply by 2ab over 2ab. And what I get is this result. I get 3c times both terms in the top. So 3c times 8b is going to get me 3 times 8, which is 24, and b times c, which is just bc. And of course, I multiplied to this term as well, so I'm going to get 9 acs here, plus 9 acs. So distribute to both terms. And then in the bottom, I'm going to get 6ab, and then times c. So looks like our common denominator when we get these, because 3c times 2ab is the same thing here, right? We're going to get 6ab for both of these. So minus, in the bottom, I'm just going to write 6abc really quickly because that's exactly what we'll get. And in the top, again, I'll distribute to both terms. So I'm going to get 2a squared b, because 2 times a times b is this. And then I'll distribute this to this term here, and I'll get minus 4ab. And of course, I can write these all over 6abc, because I'm dividing this by 6abc and dividing this by 6abc, so I can just divide them both at the same time. And then I can write the top all together. It doesn't look like we have any terms that match BC's, AC's, A squared B's, AB's, right? So I can't combine them into one term, but I can write them all next to each other. And then a word of caution right here, because of this minus sign, when we minus this, right, this whole thing here, we are minusing that basically in parentheses, right? We're saying minus all of this, treat it like it's one term, right? And so when we write this, we're going to write 24BC plus 9AC. And then we're going to minus this in parentheses, or more commonly, we're going to minus each individual part. So we'll minus 2A squared B, and we'll minus negative 4AB. Because of those double minuses here, we're going to get an addition sign for AB. Just the simpler way to write it. And there is our single fraction. Now, is it in simplest form? We'll worry about things like that later, but that gets us our fraction. Here's another example with lots of terms in the top, right, and in the bottom. And a couple things I want to talk about is if we have multiple terms in the bottom, you're not allowed to just cross things out. Like, oh, I see an A here, I'll cross an A out here and here. Doesn't work that way. Before we start crossing things out and dividing things out, because that's really what we're doing. When we cross things out here, we're going to be dividing things out. We're going to factor things out first. So to factor means to turn it into a multiplication problem. So like if I have the number 24 and I say factor 24, you could write that as, I don't know, 12 times 2. There's lots of factors. You could also write it as 6 times 4, etc., etc. So I'm going to write the top as something times something. And the way I'm going to do that is I'm going to ask, what's the common factor between the first two terms? So if there is a common factor between the first two terms, and there is in this case, we're going to write that. So it looks like there's a common factor of 2 between both of these, because this is 2 times 1 and that's 2 times 2. And there's a common factor of A times 1 and A times A. So I'm going to write 2A, and I'm going to multiply that by what's left over in these two terms. So that's why I'm using parentheses, because there are two terms. We're treating it as if it's one. So 2A times what gets me back to this is how I should be thinking. So 2A times A gets me 2A squared. And then 2A times what gets me this? Well, clearly a negative, right? 2A times a negative something gets me negative 4A. Well, if I double it, I'm going to get 4A. So that's what I need. So this can be rewritten as 2A times A minus 2. Just like 24 can be written as something times something. This could be written as something times something. In the bottom, I can see that we have a common factor of 3, but they don't have a common factor of A. And that's fine. So just 3. And what will be left over is A. 3 times A is 3A. And 3 times negative 2 would get me 6. So this is the same thing as that. Always check to make sure we're not changing the problem, right? We're just thinking of it in a different way. 3 times A minus 2 is the same thing as 3A minus 6. 2A times the quantity of A minus 2, same thing as 2A squared minus 4A. And what you'll notice now is because it's multiplication, we can divide things out, right? If I had a problem like 6 times 3 over 3 times 2, I can divide things out or multiply. Either way will work, because multiplication and division are the two sides of the same coin, right? You can do them in any order you want. So I'll divide first. Anything divided by itself is 1, and that's why we're crossing these things out, right? We're dividing out. And it's important to note that we're dividing because not always do you cross things out and they go away. For instance, when I divide 6 by 2, they don't both become 1. The 2 does because I'm dividing by 2, but the 6, when I divide by 2, becomes a 3. And so when I do this, I'm going to get 3 times 1 in the top and 1 times 1 in the bottom, otherwise known as 3. And that's exactly what we would expect to get, right? Originally, we had 6 times 3 divided by 3 times 2. That's 18 divided by 6. That is 3. So once we have all multiplication, something times something, we can divide things out safely without having to worry about goofing something up here, right? We can't just divide out an A, and you'll see that in a second, but we can divide out an A minus 2 from everything. Anything divided by itself is 1. Here, nothing else divides out. And so what I'll write is I'll write 2A times 1, which is just 2A, and 3 times 1, which is just 3. So this first term here all simplifies to this. So before getting common denominators, it's often best to see if you can simplify first. Because if I didn't simplify, I'd be multiplying this by 8b minus 16 in top and bottom, right? And I'd be multiplying this by 3a minus 6 in top and bottom, which is much more work than I'd like to do. So if I can avoid it, I should simplify. Over here with this term, I notice that I can take out a common factor of 2b from both of these, and I'll be left with b minus 4. Again, if I distribute that back, I would get 2b squared and negative, whoops. See, this is why you gotta check. This needs to be a 2. 2 times 2 will get me 4. So I'm gonna get negative 4b here. Always double check to make sure you haven't changed the problem. If I put a 4 there, I would have gotten 8b, right? They would not have been equal. So I would have changed the problem. Here I can take out an 8 from both, and what I'll get is b minus 2. And in this case, again, this isn't always the case. It looks like I can divide out this large term here. I'm not dividing b and negative 2 and negative 2. I'm dividing out this entire term, because that's what parentheses says, right? Treat it like one term. This gets divided out and becomes 1. Over here, I can divide it again. But again, everything's not going to become 1. I'm going to divide this and this by 2. So I get 1 over 4. Because that is 2/8, a quarter, right? And I get 1 times b times 1 in the top, which is just b. Again, don't forget there's a b still here. I divided out the 2, not the b. And then I have 4 times 1, which is just 4. So now that I've got this, then it's just a matter of getting common denominators and a way we're familiar with. 4 over 4, 3 over 3. Looks like 8a over 12 plus 3b over 12. And good thing these are common denominators. That's why we did this, right? They better be common once we're done. And it looks like all together I'm going to get this. These can't combine because they're a's and b's, but I can divide them both by 12 at the same time instead of dividing them individually. So all of this simplifies to this. Could you have started out by multiplying by denominators? Absolutely. You'd have to distribute a bunch, right? It'd be a lot more of a pain. So if you can simplify, go for it. If you can't, you're just going to have to go through the pain of it. Let's see if there's anything else we need to talk about for today. Oh, that's right. I want to demonstrate one more time that you can't just divide things out if there's addition and subtraction. For instance, if I have 10 over 5, that's clearly 10 divided by 5, which is 2. But if I have 10 over 5 written like this, it'll still be 2 because this is still 10 divided by 5, right? But it cannot be written like this, 10 divided by 3 plus 10 divided by 2. This is a really common mistake. And you'll see why it is, right? This should equal 2, right? Because 10 divided by 5 and 10 divided by 3 plus 2 is the exact same thing, right? But we can't split it like this, and you'll see why in a second. 10 divided by 3 is about 3 and change, right? And 10 divided by 2 is already, we already know what that is, right? 10 divided by 2 is kind of the inverse of this. It's 5. So altogether, we should get about 8 point something. And you'll see that's clearly not the right answer. This should be 10 divided by 5, which is 2. So you can't divide things individually when there's a plus sign in the bottom like this. Doesn't work. Same thing with the minus, right? There's multiple terms down here. You can't split it and divide like that. It just doesn't work, which is why it's always a good idea to factor anything with multiple terms as much as possible before you get going. And then don't just cross things out randomly. If you can't take things out after factoring, then there's nothing you can divide out. Last thing I want to look at real quick is this problem string. A string of problems that I think can be helpful to review some adding fractions. Let me see if I can pull it up. Here it is. This is what I think you should try to test your knowledge. Obviously, work on the stuff in the book. Find problems similar to what we talked about here. But here's some stuff that's kind of a review from pre-algebra. We're going to actually have some mixed numbers here. I never use these. 9 and 9/10 plus 1/10. See if you can do that in your head. And then if you can, jump to this, 9 and 9/10 plus 1/5. You can do that in your head. 3 3/4 plus 1/4. 3 3/4 plus 1/2. And see if you can see the lesson that's being taught here through this problem string of these related problems that are guiding you through fraction addition. This also works for subtraction, of course. And then see if you can try this last one. Whoops, that's a 7. 7 and 7/8 plus 1/2. Let's zoom out. See if you can give this problem string a go and see if you're able to understand the logic being expressed here in addition to the stuff we talked about.